Hi, this is Specials Getford with my 5th video of my portion series. This one I want to just go over divisibility rules, so testing what factors go into other numbers, testing divisibility of things. So I want to go over some basic ones that if we can understand these, you can easily find factors of other numbers. And if you can find factors of other numbers quickly, you can simplify fractions easier. You can make the problem simpler for yourself. You can also give yourself little hints on what the answer ought to be. If you're given a kind of problem and you know the answer has to be something divisible by 3, check the numbers, check the answers, and if there's only 2 questions that are, or 2 answers, 2 possible answers that are divisible by 3, then you can narrow your choices down and then see which one is more logical. So which one is bigger, which one needs to be smaller. So let's start with 2. Testing to see if something's divisible by 2. That's just testing the last digit and seeing if it's even or not. We know that 4 is even because I can cut it in half. 2 and 2. I know that 10 is even because I can cut that in half. 5 and 5. But what about bigger numbers? Like, let's say 3,679,112. How do I know if this number is divisible by 2? I check that last digit, 2. We know 2 is an even number. That means I can cut this whole thing in half and not have any fractions or remainders left over. So that is definitely divisible by 2. If it was that same number, but let's say I just added 1 more, that would not be divisible by 2. That last digit is 3. That means when it comes down to it, I'm going to end up dividing 3 in half. Well, I know if I do that, I will get 1 1/2 and 1 1/2 if I cut that in half. I know that tells me I know for 100% certainty that it will not be divisible by 2. Now this relates to divisibility by 4. I'll go over that one, then I'll go to divisibility by 3. So, divisibility by 4. If you can, now, let's see, just cut the number in half. So, the last 2 digits can be cut in half twice. Now, where would we come up with such a crazy rule like that, where the last 2 digits can be cut in half twice? Well, what are the last 2 digits on any number? If I took a weird number like 3 million again, like let's say I'll just skip to the part here. So I have 124. Well, I don't need to check to see if I can cut this number in half and then cut it in half again. I just need to check to see if those last 2 digits can be cut in half twice. Can I cut 24 in half twice? Well, let's see. Half of 24 is 12. Half of 12 is 6. So yes, this one is divisible by 4. Now, why is that? Well, we know that 100, or 4, it definitely divides 100. It divides 100 evenly. That's kind of a weird symbol to use here. So I'll say 100 divided by 4 is 25. Well, that means I only need to check further than the hundreds place, that 2 right there. Because if it goes into 100, it'll go into 200. And then if it goes into 200, it'll go into 300. So it'll go into 1,000, because 1,000 is just a number of groups. It's 10 groups of 100. And 10,000 is some other number of groups of 100. And I know 100 goes in evenly into 10,000. And 100 goes in evenly into 100,000. That means 100 goes in evenly into 3 million. Well, now I can just work backwards. I know 100 goes into 3 million. Okay, so does it go into 5,000? Yeah, absolutely. Does 100 go into 100? Yes, of course. Okay, so that means 4 went in evenly into that 3 million, that 5,000, and that 100. Perfectly, with no remainders. That's why all I need to check are those last 2 digits. Let's try another one. If I had 6,318, is this divisible by 2? Yeah, it's divisible by 2. Sure, I'll go there. But what about by 4? Well, I have to check that. Let's divide 18 by 2. 18 divided by 2 is 9. Can I take half of 9 without getting a fraction? Well, no, because half of 9 is 4.5. So it's not divisible by 4, but it is even and it is divisible by 2. So every even number will be divisible by 2, but every even number will not be divisible by 4. However, the opposite is true though. If it's divisible by 4, it absolutely is an even number. All right, I want to talk about divisibility by 3. Three is kind of an interesting one. Kind of plays by its own rules. The sum, to tell if a number is divisible by 3, the sum of digits, of all the digits, are divisible by 3. So I had a big number again, like let's say that 3,522,000. Okay, let's check that. I don't want to divide the whole thing by 3 yet. I know that 3 will go into 3 million, sure. Okay, does 3 go into 522? Well, let's find out. Let's actually test the whole thing here. So what are my digits? My digits are 3, I have 0, so I'm not going to include those in my sum here. So 3 plus 5, so 3 plus 5 plus 2 plus 2. Those are all my digits, all my non-zero digits added together. Well, what are they added together? 3 plus 5 is 8, 8 plus 2 is 10, 10 plus 2 is 12. Does 3 go into 12? Absolutely. So this number is divisible by 3. And the funny thing about 3 is that I can even take the sum and I can split that apart and go 1 plus 2 to get 3. Is 3 divided by 3? Yes, it is. So with 3, you can even apply that rule to your sum that you get if you really needed to. Let's say division isn't your strong suit. You added up all the numbers, you added up all the digits, and it came to something like 327. Well, then you have to divide that by 3. Well, let's just add those together, and I get, let's see, I get 12 again. Okay, that is divisible by 3 because I know that 1 plus 2 is divisible by 3. So let's see. If I had 3,004, well, I'm going to be an equal sign there. 3 plus 4 equals 7. Is 7 divisible by 3? Nope, absolutely not. But I shouldn't have to use the divisibility rule for this. I know intuitively that 3 goes into 3,000. In fact, it goes into 3,000 1,000 times. So then 3,000 plus one more 3 would be 3,003. And I know that I won't be able to add groups of 3 to 3,000 and get 3,004. I know that's not possible. Okay. We'll go to 5. Kind of going out of order for a second here. Actually, I want to do the divisibility rule by 6 before I do that one. The only reason I'm doing this order is because I'm trying to put ones together that relate to each other. 6 is interesting because it's a combination of two other rules, and that's the 3 rule and the 2 rule. Here's how to tell if something is divisible by 6. It's divisible by 2 and 3. Well, okay, that makes sense. I know that 2 times 3 is 6. So how does that affect it? Well, I know that if I could add 3, a certain number of 3's to get a number, right? 3 plus 2 plus 3 is 9. But that doesn't necessarily mean I can go 2 plus 2 a certain number of times to get 9. 2 plus 2 plus 2 plus 2 is 8. If I add one more 2, I'll get 10. So 9 is only divisible by 3, but not 2. But let's say I added one more 3. I would have 12. Okay. Let's see. Well, let's try and add a certain number of 2's to get 12. Can I do that? 2 plus 2 is 4. Plus 2 is 6. Plus 2 is 8. Plus 2 is 10. Whoops. Plus 2 more is 12. Okay. So 6 groups of 2 is 12. So I said 6 because I added 6 2's. Okay. So that works. But why does that work though? Well, if 2 goes into it a certain number of times, it doesn't necessarily mean that 3 will go into it. But if 3 and 2 both go into it, well, I can group my 3's and my 2's into groups of 6 to get 12 and 12. I can take 3 plus 3, that's a group of 6. 3 plus 3, that's a group of 6. Let's see, 2 plus 2 plus 2, that's a group of 6. 2 plus 2 plus 2, that's another group of 6. I can do groups of 6 to get those numbers that are divisible by 2 and 3. So another way to think about it is that the sum of the digits are divisible by 3. I'm going to put the divided sign for divisible by 3 for now to save room. And it's even. So it has to be even and divisible by 3. So maybe we'll pause and look at those other numbers that we did. The one that was divisible by 3 and was even, if you check that last digit was even, then that number was divisible by 6 as well. All right. Let's check our divisibility by 5. The last digit is a 5 or 0. So what does that look like? Well, we know that 5 goes into 10. We don't really need to use the divisibility rule for that. We can just add 2 5's to get 10. Well, that means any number that's divisible by 5, I should be able to add a certain number of 5's to get that number. Okay, well, what about 55? Is that divisible by 5? Well, yeah, because I know that 5 goes into 50. And if it goes into 50, I just need to add one more 5 to get 55. In fact, 5 times 11 would be 55. So that one absolutely is divisible by 5. What about numbers that end in 0? If I have like 3,140, I don't know off the top of my head how many times 5 goes into that. But I do know, and just like we know with the 4 goes into an even 100 a certain number of times. 5 goes into 100 an even number of times. So that means 5 would go into 1,000 an even number of times. Therefore, we know that 5 will go into 3,000 a certain even number of times. Okay, so it goes into there an even number of times, and then it will go and do that 100 an even number of times. Now we just have to check the 40. Well, does 5 go into 40? Well, I know that 8 times 5 is 40. Okay? So yeah, that one absolutely is divisible by 5. And in fact, this one's divisible by 5 and 10. So here's a quick rule for divisibility by 10. last digit is a 0. Does 10 go into 1,000? Yeah. Does 10 go into 3,000? Obviously, if it goes into 1,000. Does 10 go into 100 then? Yes. Goes in 10 times. Okay. Does 10 go into 40? Well, yeah. 4 times 10, 4 groups of 10 would be 40. That's absolutely right. In fact, when you multiply a number by 10, if you were to take the number 3 and multiply it by 10, you're going to get 30. Or the easy trick to remember is if we're multiplying any number by 10, like 375 or let's say 3,754, for example, times 10, all you have to do is just add a 0 to the end of it. So that'd be 37540. That would be the number times 10. Well, that having a number ending in 0 tells me that, well, perhaps if I looked at that number, if I saw it on the street randomly, let's say, I could think to myself, well, someone may have multiplied 10 times the number to get that. And that number would just be that same one, just minus that 0. So anything ending in a 0 is a multiple of 10. There's only one more rule I want to go over that I think is important. I think in the book it'll give you a rule for 8. So it's kind of interesting. Well, it's not super interesting because they build that rule the same way you can build a rule for 16 if you wanted to, based off the same logic. If 2 and 4 go into it, sure. So I guess if you took the last 2 digits and cut it in half twice and got an even number, well, then you just have to check to see if that number is even and can be cut in half again. Because dividing something by 8 is the same thing as cutting in half 3 times. So cutting in half 3 times. Of course, 1 half times 3 isn't that, but yeah. So cutting in half again, then cutting in half again. That's not super important. If you needed to, you could build that easily just by using the 4 rule and then checking if that answer is even. The only other rule I want to go over is 9. It operates very much like 3. So the sum of digits add to something divisible by 9. For example, 9 times 9 is 81. So 8 plus 1 equals 9, and we know that 9 is divided by 9. If I took any other thing like 63, let's see. That actually, I know for a fact that is 9 times 7. Well, 6 plus 3 is 9. Check. What about other numbers? Like bigger than 100? If I had 234, well, let's see. 2 plus 3 plus 4. Oh, that does add up to 9. Okay. So if I were to check on my calculator, I could go with 234 divided by 9, and I would get some even number. Okay, so that's all I wanted to show you for that. The next video on simplifying fractions, we're going to use a lot of these divisibility rules, so I strongly recommend trying out the practice problems for this video in the description below on the YouTube video, or you can check the classroom folder for the 5th quiz. I'll have a 5 in front of it. All right, I'll see you in the next video.